All right, hey guys. So today's video lecture is from Unit 5 over chemical measurements. Um, Now, when we're talking about chemical measurements, um, what we're talking about is uh, measuring substances on a micro level, like a level of like atoms and stuff like that. We already know about measuring, with mass in grams and uh, volumes in liters and all that kind of stuff. This is like, how do you actually, now that we know that there are atoms that make up our elements and stuff, how do we go about measuring, uh, making measurements of these things that we've done in chemical equations, and talked about in the concepts about them. So the first thing we have on here, something you're probably familiar with, is the atomic mass. Atomic mass is the mass of an atom relative to the mass of a carbon-12 atom. What they did is you have to have a standard by which to measure things, right? Like, who decides how long a foot is? Well, there has to be a standard. There has to be something that says, like, this is what a foot is. Okay, you say, well, a foot, I mean, if it has to be, if a foot has to be 12 inches. Well, then what's an inch? So, like, somewhere there has to be a base standard of something that says, like, this amount is what this measurement is, right? So when they're talking about what's atomic mass, they had to have a standard to set it to. So the standard they have is what they said is a carbon-12 atom. Remember, the 12 is the mass number. Okay, so they basically just said a carbon-12 atom, like that atom, is going to be 12 AMUs. AMU stands for atomic mass units, and it's literally a unit label made up to measure masses, masses of atoms. Okay. So for example, the atomic mass of Be is 9.0 AMUs, atomic mass units. The mass of magnesium, 24.3 AMUs. So that's just off of here, right? The atomic mass on your periodic tables. And I'm going to I'll put periodic table so you can get copies of them in the resource section for the class. Okay. It's not auto-focusing on that very well. Don't know why. There we go. So the atomic masses. Okay. All right. There we go. Formula mass. Formula mass is exactly what it sounds like. It's the sum, adding up of all the masses of all the atoms in a compound. The formula mass is also measured in AMUs. How do you calculate it? Well, you take the number of atoms of one element in the compound times the atomic mass of one atom of that element. And that equals the total atomic mass of that element in the compound. Then you add all of the total atomic masses for each element together to get the formula mass for the entire compound. Okay, that's how you do it in words. It's actually a lot easier if you just see it done out, like down here in the example. Find the formula mass for water, H2O. So we have forget you can see this. So we list out the individual elements, H and O. Okay, we put the number of atoms of each one. There are 2 hydrogen, there's 1 oxygen, so 2 and 1, times the atomic mass. Now, I want you guys to take the atomic masses off the periodic table to at least 1 decimal place. Okay, that means you're going to look at least 2 and then round to 1. So like hydrogen is 1.00, so it's 1.0. Oxygen, okay, 15.99. So the 9 rounds up, rounds that, bumps that to a 0, rounds that, so it's 16.0. Take each of them to 1. to 1 decimal place, okay? Now, you don't know, I'm writing like 1.0 just to show you that I went to 1 decimal place. You could just write down 1, but just know that if there should be another digit in the 10th spot, you need to put it, okay? So 1 for hydrogen, 16 for oxygen. So you take the hydrogen, 2 of them, times 1, gives you a total of 2. Oxygen, 1 times 16 is 16. Then all you do, so like this is the total AMUs for all the hydrogen, this is the total AMUs for all the oxygen. Then you just add it together. That gives you the formula mass, 18 AMUs. That's the formula mass for water. Okay. Here's another example. This one is a little more complicated, the formula. So it's aluminum sulfate, Al2SO43. So the way we do it is the same way though. Take the element, you break it down into each individual element, so aluminum, sulfur, and oxygen. Then you count the number of atoms. So in aluminum, there's 2. In sulfur, sulfur is in here, right? So there's 1 sulfur in here, but it's in the parentheses, and there's a 3 outside of the parentheses. So the number outside of parentheses, you take times, not added, times any numbers that are inside. So a sulfur has a 1 times 3, 3 total sulfurs. Okay, oxygen. Oxygen's here, oxygen has 4. And then it's inside the parentheses, so times 3, 4 times 3, means there's 12 total oxygen. Okay, get the number of atoms for each. We find the atomic masses for each. Okay, aluminum 27. Sulfur, I'm going to show you because that one has something in there. So if you look at sulfur, and this is why you got to kind of watch. Okay, let me zoom in a little bit here. I don't know if it'll focus that well on that or not. Get my hand out of the way. Okay, sulfur is 32.065. I want you to go to at least 1 decimal place. Now, if you want to write the whole thing out, that's fine. I wouldn't mark that wrong. But go to at least 1 decimal place. So 32.06. The 6 is going to round the 0 up to a 1. So it's going to be 32.1. So 32.1 is the mass for sulfur. Oxygen is 16. And we multiply 2 times 27 gives us 54. 3 times 32.1, 96.3. 12 times 16, 192. Add them all together, 342.3. AMUs is the formula mass for aluminum sulfate. Okay? All right. I'm actually going to skip this part of the notes down here for now. If we need to later, I'll go back to it. But I'm not going to worry about this for right now. Okay? All right, let's go to the second page of the notes.